In example 19, there's a diagram that is drawn, and we are told that this is the graph of y is equals to the function of x. It has some particular points whose coordinates are given. Of course, you know the point. There is a point A whose coordinate is minus 7, 0. There is point B whose coordinate is minus 2.5, 15, C, 0, 11, D, 3, 0, and E, 6, negative 5. In part A, we are supposed to sketch the graph of y is equals to modulus of hx. This means it's the whole function that is moduled. That means entirely we are not expected to give the value of y in negative forms. That means what? This means all negative values of y are reflected along the x-axis, and that is exactly what we need to do, because the whole thing is moduled. There is y is not permitted to be negative, just in short. So in this case, we're supposed to have it this way. Negative x remains negative 7, remains negative 7, but this part of the graph that is reflecting negative y, it's supposed to reflect now positive y. And of course, all these points, there is point B, which remains 2.5, 15, and there is point C, which remains 11. That part, all those parts, until when x is equals to 3, again we now get to the positive side, and this is the part which now reflects. This is the part which reflects along the x-axis, of course, to the positive value of y. And you can see point E particularly is the one that is supposed to be captured very accurately, that the new point E is supposed to have coordinate 6, 5. Note that the 5 is now positive and not negative. So in a nutshell, that is exactly what we need to show. All the negative values of y have been reflected to the positive values. Now, this is the graph of y is equals to the modulus of the function of x. Part B, we are supposed to show, to sketch y is equals to, supposed to be the function of x modulus. Now, in this one, we are supposed to really understand that it is only the value of x that is moduled. So when x is positive, we have no problem with it. We can even talk about it. When x is positive, we can start from 11 all the way to 3, that part, and point E is 6 minus 5. Those are the values of y when x is supposed to be positive. But in case x is supposed to be negative, for that matter, every negative value of x is supposed to be moduled, giving it the corresponding value of positive x, and therefore the corresponding value of y. So, for instance, if x happens to be 3, the value of y is 0. If x happens to be negative 3 for that matter, the value of y should not change. If x happens to be 6, the value of y is minus 5, somewhere there. If x, somewhere here. If x happens to be 6, the value of y is negative 5. If x happens to be negative 6, the value of y should not change. And why? Simply because even when x is negative 6, Negative 6 moduled is 6, and we have now the function of 6, which originally gave us negative 5, which must be reflected here. So in a nutshell, we are supposed to simply reflect that part of the graph along the y-axis, giving us something like this. And these coordinates, again, we capture this is negative 3. We capture this particular point as minus 6, minus 5. That is exactly what we need to show. And we label this graph as y is equals to the function of modulus of x. Only x is module. So y is not moduled. It can have positive or negative values, but x is only allowed to have positive values. And that is just like it as far as that example is concerned. Please take note the difference between the two. Okay?